Okay, so we're going to continue on with 8.3, and at this point we're going to go ahead and look at using T procedures wisely. So procedures that are not strongly affected when a condition for using them is violated is called robust, and that is a really important term, robust. So even though we violate a condition, but our answer still ends up pretty accurate, that's robust. Now, for confidence levels, robust means the stated confidence level is still pretty accurate. And if outliers are present in a sample, then the population may not be normal, and T procedures are not robust against outliers. So if you have an outlier, let's say we don't meet the normal condition, like our last problem. We had only 18 toilet paper rolls, so we did not meet the normal condition, so we graphed it using a normal probability plot. It looked pretty normal, so we went ahead. Well, if we had an outlier, then we wouldn't be able to use the data because, again, T procedures don't work when you have outliers. So, things that you want to know are things that change about the normal condition. So now we have kind of a new normal condition because we get a little bit, as we get our numbers lower than 30, there's a little bit of a give room. And so here are our things. If our sample size is less than 15 and it appears close to normal, so our last one, it looked pretty linear. It had a little bit of a tail up at the end, but it looked really linear. Then we can use T procedures because it looked really close to normal. But if it's skewed in any way or has outliers, we cannot use T procedures. So on our next one is if the sample size is at least 15. And so this is really 0 to 14, though I don't know why you'd have a sample size of 0. So if our sample size is 0 to 14, and it's close, it looks pretty symmetrical, it's close to normal, you're okay. You can still do it. If your sample size is 15 to 29, then you can use the T procedures as long as you can use it if there's skewness, but you can't use it if there's outliers, and you can't use it if there's a very strong skewness. So there can be skewness, just not strong skewness. There can be moderate skewness. And then our last one is large samples. So anything 30 plus, we're good on. So now we've kind of updated this normal condition for our means. And again, this only applies to means. So if it's less than 30, then we have to graph it and we have to take a look at it. So when we were looking at our last problem in our notes, the graph was pretty linear, so we were good because we were right at 15 or 18. We're in between this area. We're in 18. There was no strong skewness. We had a little tail at the end that kind of went up, but it was not that big of a deal, so it was good to go. We also have a one sample T procedure on the calculator. There's several different ways you can do it. This one on the left-hand side is if you have individual data. So in our last problem, we had individual data. We could put it in here, and it will do the test for us. It will not check conditions, so you still have to check conditions yourself, meaning you may have to graph stuff up here to see if it's skewed or if there's outliers. And then over here is if they only give you the mean and standard deviation. So they don't give you the individual data, but they do give you the mean and standard deviation. Again, this is really more to check your answers to make sure you're doing it right. So we're going to go ahead and we're going to move on to our next problem. It is a free response problem. In fact, it's our last free response. And remember, with free response, we need to go through and do, oops, I'm on pen again instead of highlighter. We need to do our state, plan, do, and conclude portion. So we need to go through all those steps. So how much homework? A principal at a large high school claims that students spend at least 10 hours per week doing homework on average. To investigate this claim, an AP Stats class selected a random sample of 250 students, so sample of 250, from their school and asked them how long they spent doing homework during the last week. The sample mean was 10.2 hours, and the sample standard deviation was 4.2 hours. Construct and interpret a 95% confidence interval for the mean time spent doing homework the last week for students at the school. So now we're going to estimate our mean time spent doing homework in the last week for students at this school with 95% confidence. We're going to use a one sample t interval. And t intervals are for means. And now we're going to check our conditions. So is it random? Yes, we had a simple random sample of 250 kids. Is it normal? Well, our sample, 250, is greater than or equal to 30, so we're good to go. Is it independent? Well, it's reasonable to assume there's more than 2,500 students. In a large high school. And that's why they say at a large high school, because in everywhere but Alaska, a large high school easily has more than 2,500 students. We're looking at more like 4,000 students. Okay, so now we're going to go ahead and calculate our information. So we already have X bar calculated. We already have our standard deviation calculated. So all we need now is our inverse t. And our inverse t is going to be for a 95% confidence interval. So that means we're going to have an area of 5% divided by 2. And then our degrees of freedom should be our sample size minus 1, so 249. And that's going to give us an inverse t of 2.898. Sorry, that number seemed too big. So inverse t 0.025, degrees of freedom 249, so this is 1.9695. And so now we're going to go ahead and we're going to calculate. So we're going to start with our X bar, our point estimate. We're going to add and subtract our t, 1.9695. We're going to times by our standard deviation, 4.2, and divide by the square root of our sample size. So we're going to go ahead and calculate this. So I'm going to take that 1.9695, I'm going to times it by 4.2, and then divide by the square root of 250. And I get 10.2 plus or minus 0.523. And I'm going to take that 10.2 and I'm going to subtract 0.523, which gives me a lower bound of 9.677. And then I'm going to take that 10.2 and I'm going to add 0.523, and that gives me my upper bound, 10.723, which means that now we can go ahead and conclude we are 95% confident that the interval from 9.677 to 10.723 captures the true mean of time spent doing homework in the last week for students at this school. So now we have kind of a follow-up question. Based on your interval, what can you conclude about the principal's claim? So what was the principal's claim? The principal at a large high school claims that the students spend at least 10 hours per week doing homework on average. So do they spend at least 10 hours per week? So when I look at this interval, 10 hours per week is in the interval, but could they actually spend less? Are there any numbers in my interval that are less than 10? And yes, there are. So it is possible that students spend less than 10 hours a week on homework. And that's our average. So it's possible, because there are some values in here that are less than 10, anywhere from 9.677 up to 10. There's not a lot of room for that, but there is a possibility that students spend less than 10 hours per week on average doing homework. Okay, so that's it for there. I just wanted to point out really quick our Garfield comic. Taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above zero, which is such a wide interval that it means that the guy's never wrong. Well, not never wrong, but depending on where they are, probably never wrong. And so too wide of an interval doesn't help anything. It doesn't give us any information. So just kind of reinforcing that fact.